Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, Senior 4 chemistry students. Welcome back. Alan is my name, still with you in the chemistry lessons. I hope you're fine, and I am pretty okay and happy to still be interacting with you. Welcome and join me. So today we are going to be looking still on our topic of the periodic table and unit 14, which is about the trends in the properties of period 3 elements and their compounds. We are heading in for our last lesson on this topic and all the units that we've looked under this topic, and that is the melting and chemical reactions of chlorides of period 3 elements. Having looked at the oxides as one of the compounds of period 3 elements, in the last lesson we started on chlorides of period 3 elements, and we basically looked at the preparation and bonding type and how it is really bringing in the different physical properties. So now we are going to the melting point and the hydrolysis reaction. But before we look at today's work, let me bring to you the lesson objectives. Usually I have to outline what will be making up the lesson and the key terms for you not to miss, because those key terms normally go hand in hand with the lesson content. Then we can highlight the objectives. Starting on what we shall look at will be the reaction of chlorides of period 3 with water. Then we also look at the melting points and how bonding influences the melting points. Then, when we are talking of reaction, I want you to remember this term. When chlorides are reacting with water, we call it hydrolysis. Basically, the word hydrolysis implies the reaction of a substance with water. So, we're going to be talking of hydrolyzed or hydrolysis. That is the term we are to be using when we are looking at reaction of water with substance. Then when you're explaining melting points, please, as I again emphasize this, do not forget these terms, because they're like giant ionic lattice, or is it a simple covalent molecule? What are they? They bring about, those are the scientific terms that bring about the understanding. Someone who is simply listening to you and you mention of the simple covalent, if he's a scientist, he will have the idea. So what I'm saying is, as we're looking at the melting points, we always relate it to the bonding, and these are the terms involved in bonding. So the objective, they actually, I would call them two, but I generalized it and called it one, is to discuss how the nature of bonding influences the melting point, or how the chlorides interact with water. Do they all undergo hydrolysis, or we have some which do not undergo hydrolysis? So that is about the bonding and how it brings about those changes, as we are going to see or to look at them in our next slides. So that is what makes up the lesson content. I'm not leaving out the topic assessment. As I told you, we are concluding the whole learning in Senior 4 about periodic table. The other part, you'll find it in Senior 6. I will also highlight about it. So, to the students who aren't with us in the previous lesson, that is lesson 4, please, endeavor not to miss this content. As again, I always encourage you, if you missed a lesson, try to find it and do not miss that content. So if we can make a quick review for lesson 4, we looked at preparation of the chlorides of period 3 with specific emphasis on sodium, magnesium, aluminium, silicon, and phosphorus chlorides. Then we also looked at their bonding in details and the uses of those salts or of those chlorides. So, in brief, all the chlorides, mostly they are prepared by combining the element with chlorine. Of course, there are a few exceptions, like we use the compound of chlorine, which is HCl, when you are preparing the chloride of silicon. That is silicon tetrachloride. So when they are prepared, we can have this table generalizing much of the work we covered at. We looked at their formulas and how they exist at room temperature, that is at 25 degrees Celsius. These exist as solids, whereas silicon tetrachloride and phosphorus trichloride exist as volatile liquids because of the weaker forces of attraction in them. Then phosphorus pentachloride exists as a solid because of that anomalous behavior. We looked at it, and basically the formula is normally written as P2Cl10. And as you would imagine, the bonding, that is ionic for sodium up to magnesium, covalent for aluminium because of its polarizing power, and the rest being nonmetal or having nonmetallic properties, then they exhibit covalent. This is a bit unique. Remember, we looked at it. And those are the uses. Basically, that is what we looked at in lesson 4. I emphasize the point if you missed due to many reasons, try to always go back and find out what was covered so as you do not miss a lot. So that is it with the review. We can now go to today's work, which is first reaction of period 3 chlorides with water. I'm pausing a bit because I want to bring the whole of this for your understanding. These chlorides, as we noticed, they are of two categories. We have the ionic bonded chlorides and the covalent bonded chlorides. So, as we are going to look at their reaction, their interaction with water, we have to put in consideration that kind of bonding. How is that bonding bringing about the interaction in water? Let's use the ionic chlorides or the ionically bonded chlorides, and that is magnesium chloride and sodium chloride. When I talk of sodium chloride, I mean this common salt that we eat. Yes, it is the sodium chloride that we even use in lab, except that the one we eat, they normally add some iodine, and that's why it is called iodized. So these chlorides are ionic. They have ionic bonding. And as such, they dissociate in water, forming solutions with neutral pH. That's around 6.5 to 7.5. So by the mere fact that for them they do not react but only dissociate, then it is simply separating the ions, making those solids or making the crystals. For instance, the crystals of sodium chloride, when you dissolve it in water, it is separated, putting sodium ions aside and the chloride ions aside. So aqueous, this implies aqueous, meaning dissolving in water. For them, they do not react. So we do not bring water as a reactant in there. And you take note on the pH. This is slightly less than 7 because of the slight covalent nature in magnesium chloride brought in by the polarizing power of magnesium cation, having a positive 2 charge in here. It slightly polarizes the chloride, bringing the pH to be not exactly neutral as 7, but slightly. Now, let's understand when we talk of dissolution or dissociation. Imagine you're having sodium chloride, that common table salt, and you're adding it in a glass of water or a saucepan having water. As you dissolve, what happens is if we take this to be water molecules and this the crystal of sodium chloride. As you stir using your spoon or using what, it is separated. That crystal is separated into different ions. So the exact chemistry that is happening in that saucepan or that glass of water that you've added sodium chloride is the crystal, which is made up of chloride ions illustrated by this green color, and the sodium ions illustrated by this purple color. This crystal is disintegrated. It is broken down. The water molecules break it down and surround each ion with the respective component on the water molecule. What do I mean by the component? This is the water molecule having oxygen and hydrogen. But due to difference in electronegativity, the hydrogen is having a partial positive because electrons are towards more of oxygen than hydrogen. Then the oxygen has a partial negative. So sodium ion being partially positive, having a whole complete positive, take note on that, it attracts the partial negative on oxygen in the water molecule. Then the chlorine having a negative charge, it attracts the partial positive of hydrogen on the water molecule. So they get surrounded by water molecules, forming what we call the hydration shell. So, and this is what happens. The crystal is simply separated, putting one ion aside and another ion aside. And that is what we basically write as positive aqueous, chloride negative aqueous, like that, as simple. So that is exactly what happens when we talk of ionic chlorides simply dissolve in water. They do not react, or they do not produce other more different products when you add them in water. Hope you understood on that point. Let's quickly now look at covalent chlorides. What happens? And as you notice, the covalent chlorides, they run from aluminum chloride downwards to silicon tetrachloride and even the chlorides of phosphorus. For these, they react, and that is what we basically call hydrolysis. They are hydrolyzed by water, and the resulting component is very, very acidic solutions with pH less than 4. Sometimes even the pH can go to 0, like for the case of phosphorus pentachloride, because they are producing phosphoric acid, and even part of it with the hydrochloric acid, which we know as the HCl. So what is happening in here is when you add this chloride in water, because of that covalent nature, the bonds are broken down, releasing the chlorine atoms or the chlorine ions, because chlorine is having more electronegative than these respective atoms. So the chlorine takes the bonded electron and it combines with the hydrogen from water to form HCl, which is a strong acid, very low. And in this HCl comes as white fumes. But basically, when you hydrolyze these chlorides, as you see my highlighter, you're producing dense white fumes. It is normally seen, and making the solution to be acidic. So you see a slight difference in here. Covalent chlorides, they are hydrolyzed. They react when you add them in water, giving different products. But for ionic, their ions are only separated from in the crystal, and that's why the salts normally dissolve. They all get consumed within the water. You don't see more of the salts. So that is the quick difference that lies within the chlorides of period 3 elements. Let's go to one of the other property, and that is melting point. I want you to take a close look Look at the trend in the melting points. You see the chlorides we included from sodium chloride to chlorine. Look at the melting point. See some unique points. Look at the melting points, compare them with the bonding and structure. Similarity in the bonding and structure, you see that from aluminum chloride to chlorine, we're having covalent molecular structure. Sodium chloride and magnesium chloride, it is ionic. If we can go slowly, what do you notice as unique points in our melting point? What do you notice as unique points in our melting point? First, you see sodium chloride having relatively higher melting points as regards to magnesium chloride. But starting from magnesium chloride, the melting point is so low. Look at the gap, about 500, from 714 to 180 degrees Celsius. So these have higher melting points because they are ionic. They have ionic lattice structure. In other words, there is attraction between the whole positive charges of the cations and the negative charge of the chloride ions involved in here. So they have strong forces of attraction. These are molecules. So for them, they exist with dispersion forces which are weaker, and the dispersion forces, as we said, they are due to just the molecular size. So the bigger the molecule, then more electrons, and so there will be more dipole created, creating stronger dispersion forces. So that is the difference between these covalently bonded molecules and the ionic bonded lattice structures. But then, take a note, we have aluminum chloride, which has relatively higher compared to these, and even phosphorus pentachloride having higher, relatively higher melting points. So I pose a question, why aluminum 3 chloride and phosphorus pentachloride are having relatively higher melting points compared to their respective covalently bonded chlorides in this table? What makes aluminum chloride and phosphorus pentachloride to exhibit higher melting points? Remember our last lesson, what we looked at their bondings and we looked at all the anomalous behaviors. Now it's time you bring that knowledge in here. I'm waiting. Okay, quickly, let's see the answers. Aluminum chloride exhibits as ionic solid or ionic lattice in the solid form, whereby the aluminum ions are surrounded by the chloride. You'll know where the covalent bonding came from. So the unique aspect in here is in the solid form. It is ionic. It has ionic lattice. Same applies to phosphorus pentachloride. In solid form, it is ionic solid with this kind of structure. We looked at this anomalous behavior, and I stressed the point that it will affect its melting point relative to other covalently bonded molecules. If you recall that in the previous lesson, and here it comes. So basically that is it. Let's make a quick summary about the chlorides of period 3. Let's quickly make that quick summary. The table summarizes everything. You see the chlorides, their bonding and structure, the forces of attraction, their melting points, and what is formed when they react with water. These are they form neutral solution. pH here, slightly acidic due to the polarizing power of of the magnesium cation on the chloride, bringing in that covalent nature, meaning it is slightly hydrolyzed. Then these are completely hydrolyzed, bringing in different, forming solutions of different pH, you see. So that is it with the trends in the periodic table. If I can also make a quick summary in here. You believe with me that we've looked on period group 1, group 2, group 3, group 4, group 7, group 0, then we've just concluded period 3. As you've noticed, with this knowledge of period 3, you can transfer it even to other periods. What you will cover in Form 6 will be this part, the transition methods. From here up to here, then go down up to there. That is what you will cover in Form 6. So far, that is it with the Senior 4 periodic table. Well, let's now go to, let me cheat for you. I actually call it cheating. Let me cheat for you. So normally, when we are assessing periodic table, I want you to take note of these 4 aspects that you will always be meeting during the assessment or during the tests and so on. So first, it's involving the recall of knowledge. All that we looked at, can you really recall some of the principles and some of the components of the periodic table? When that is done, we also test the comprehension and understanding of the trends and the components of the periodic table. Then we look at you having understood and comprehended the content of the periodic table. Can you now analyze aspects within the periodic table and apply? For instance, I've told you, we've only looked at period 3. We've only looked at period 3. Can you now apply the knowledge as regards period 3 to maybe period 4 or period 5? Can you apply that knowledge? Then the last other part is about creativity. Can you use the knowledge of periodic table to create something or perform something? And this is where now the practical part comes in for you. You'll be, when you're in a practical session, you're expected to formulate the procedures, then test the procedures and get results, then find something. So this is about creating. Using the knowledge you've attained, can you create something? So this is what normally being tested on. Now, let's understand each aspect. When you're asked about recall, what kind of questions would come on the recall of knowledge? That's where you meet questions like state, name, right? Just simple recall of knowledge. Like name an element which can act as a catalyst. State the properties of maybe group 1, such a simple understanding. Then when it comes to comprehension, you're going to be meeting more and much of the questions involving describe the trends, describe and explain, interpret. Such a questions are the ones you're going to be meeting. And as I told you, I'm cheating for you. When you meet such a questions of describing, they are asking relations, relate and state. So you expected to use adverbs like the steady or steadily, the increase is rapid, or there is a rapid increase, or there is a gradual decrease, things, word adjectives of that category, and they are highlighted over here. Steadily, rapidly, gradually, those are the expected adverbs to use when you're responding to questions of describe. And do not forget, this is very crucial, scientific terms. If you check closely on our work, we've been talking of I've been giving you key terms in every lesson, like shielding effect, polarizing power. All those are what we call scientific terms. You need to connect the scientific term with the question and understanding, then you give appropriate responses. Let's take a quick example. This was the exercise 3, that is for lesson 3. And in that you'll see, define amphoteric substance, name, then using equations, explain. And describe and explain. So in here, this first question is simply about the recall of knowledge. Then in here, it is more of the comprehension. Can you state the relation as you see? Other parts that you will always see, this is a bit of the understanding, high-level understanding or high-level application, and that is the ability to analyze, evaluate, and even apply. So these have questions like predict, illustrate, and compare, as I had highlighted. Then the fourth, it is much more on the practical session, where you are creating something. You are setting rules, you're setting principles for yourself, then testing those principles, all those theories and hypotheses. Let's take an example in this category. Category 3 and 4, it's where you'll be meeting questions like illustrate, like this question. Stating your reasoning, predict. This is, for the case of silicon, it was not given, the melting point was not given to you. You have to predict it and give a reasoning. So such will be the kind of questions that you're going to be meeting. If we can do a quick summary on the topic assessment. Remember, normally you would be meeting questions in these 4 categories. Recall of knowledge involving state, define, name, and so on. Comprehension and understanding involving description and explaining, then analyze, and finally apply. So that is it with the topic of periodic table. Always I emphasize you to go and practice more, discuss more for more content comprehension. Thank you for being part of the lessons. I still remain Alan, and I'm happy to be interacting with you. Please stay safe as we look forward to meeting again in the other subsequent units and topics. Bye.